I want to go over how to use Excel to do the Poisson. So I'm going to do number 14 here from the book, and we have this disease cluster. Neuroblastoma, a rare form of cancer, occurs in 11 children in a million, so its probability is 0.000011. 4 cases occurred in Oak Park, Illinois, which had 12,429 children. Assuming that neuroblastoma occurs as usual, find the mean number of cases in a group of 12,429 children. Okay. So how do we find the mean here? Well, we are going to use our calculator. We're going to take 12,429 times 0.000011. I forgot to bring up my calculator here. Hold a second. Let me find my calculator. I was doing it on my calculator here, but you probably want to see what I'm doing here. So, okay, so 12,429 times 0.000011. This is just basic, right? So then the mean number of children we expect out of this many is less than 1, 0.1368. So this is our mean, okay? So this is our mean here, okay? So this is our first step, and we need this, remember from the formula and from how we're doing Excel, we need that mean. So your first step is always to find the mean, and usually that's going to involve the probability over the thing. So we've got this. Now, using the unrounded mean from part A, find the probability that the number of neuroblastoma cases in groups of 12,429 children is 0 or 1. Okay. So I'm going to actually do this two ways because I want to illustrate how both these formulas work. So I need x equals 0 and x equals 1. So the first thing I'm going to do is I'm going to do them individually and just sum them. Okay? Then I'm going to show you how to do them in one step. But the reason I'm doing them in two steps is I want to explain the two different formulas. So now this said unrounded mean. So I'm going to show you what I did here. Now I could have, you could do this two ways. You could come down here and you could do 12,000, I'm going to remember this number eventually, 429 times 0.000011. Okay, so that's that same number, right? So I'm going to go up here to formulas, more function, statistical, and I'm going to go down to P's, okay, and Poisson, okay? So my x here for the first one is 0. My mean, now I can do this two ways. Actually, I can do this three ways. I could copy this number, okay? I could also simply have skipped all this and do right in here, you can actually do the math. 429 times 0.000011. You can also put the cell number, B7, if you did a thing. Okay. Oh. I'm like, why is this not working? A7. Okay, A7. So I'm just telling it where to find it. So you can do this any way. You can either copy it from your calculator or from Excel. You can do the math in this box, or you can do the math somewhere else and pull the cell number, whichever works. Now, to find the individual, I want to use the probability, the individual one. So I want to use false down here, okay? And then I'm going to come down here. This is the probability, so we have an 87% chance of 0. Then I'm going to do the same thing again. More function, statistical, go back here. Right there. Okay, so I'm going to do 1 now. My mean is, I'm going to do 12,429 times 0.000011. Okay, and I'm going to use false again. You do have to be able to spell false correctly. And then I would simply sum these. So I can either use the auto sum or I can just sum this, B1 through B2. And so here is the answer, 0.991, or 99% chance that we get 0 or 1. Okay, so this is one way. You find each that they asked you for and did it. This is the long way, though. The shorter way would be here to go to more function, statistical, and come down here to Poisson. Okay, and I'm going to put in 1. I'm going to put in my mean. So I've done this all the different ways. So 136,719. Don't put the extra 0 in there. Now if I put in true, this is going to do up to. It's the cumulative, so it's going to do up to whatever the x value. So this is going to do 0, 2, 1. So you'll notice this is the exact same value I got here. Okay, so whether you use cumulative or the mass function, either will work. I just don't want to point out that difference in true and false and what you're getting. So when you use the true, you're getting everything up to that x value. So in this case, 0 and 1. If I would have used 3, I would have got 0, 1, 2, and 3. In the case of the other one, when I do 0 and 1, so this here, this 12% is the chance of getting one case, where I have an 87% chance of getting 0 and then 99 of getting 0 or 1. Okay, so those were the first two questions. So I got the mean. Okay, then I had to use the mean. Then unrounded mean from part A, find the probability of the number of mass is 0 or 1. Now what's the probability of more than one case of neuroblastoma? So at least one. We know that. More than one, right? Okay. So this is kind of a version of at least one. This is actually at least two. So more than one means 2, 3, 4, 5, so forth. Because more than one. This is saying include one. So what I want to do is I want to do the probability of 1 minus the probability of 0 or 1, which is what I just found. So I want to do 1 minus d. I don't know what I typed. Okay, 1, let's try this again. 1 minus d1. There we go. So then the probability of more than one case, so I didn't get 0 or 1, I get 2, 3, 4, 5, is 0.0085, so less than a percent point. So is those 4 cases is a red flag? Yes. That is not normal. We wouldn't expect that normally. Okay, definitely bears some investigation. So hopefully this helps you with how to use the formula and that difference between when you use true and false and the different reasons you would use them, as well as finding, I think a lot of times making sure you get that mean correctly can be a little daunting.